All right, I think we're live. Yeah, looks like we're good to go. How's everyone doing this evening? We have a lot to talk about. I've been running around like a nut all evening, all day, doing a variety of things. So let's see here. We have the storm coming up on Friday. We have the potential storm for Monday, Tuesday. We have a rapidly changing pattern. We have the evolution of spring. And we have an interesting question that's floating around on social media. And a lot of meteorologists are thinking about this. So I wanted to touch on this first. A couple of things first. Is climate change impacting the models? It's an interesting question, and I wanted to tackle it first because I think it's really important because it brings in a lot of questions about how you're using these models. Now, from my perspective, model guidance is so much improved. Okay? Climate change or not. I come from the time where you had the NGM model, which was 48 hours out, and you could trust it maybe under 12 hours. When you had, and that was it. Now that was the precursor before the ADA, and the ADA was the precursor before the NAM. And I come from a time where you had this model called the MERF, which was basically the grandfather of the GFS, the new GFS. Okay, the MERF used to produce hurricanes every 7 days out, no matter what time of year. We called them MERFicanes. Okay, so from my perspective, model guidance has significantly advanced. What I think is happening is not that model guidance is worse or that model guidance can't be trusted. It's that we are relying far too much on model guidance, like as if it's a crystal ball. Model guidance is nothing more than a tool. And because we have that tool, we've become too accustomed to just rely on that, throw out a snow map, and say, okay, it's going to do this. And then we find out 7 days later, it's nowhere near accurate. Why? Because the model guidance is only supposed to be a guide rail, especially 7 days out, not something that's supposed to be specific. It gives us an idea, okay, this is what the potential is. But then as a meteorologist, my job, not necessarily your job, your job is to be excited about it. My job is to look at it and say, okay, this is an error here. This is a factor that has to be watched for changes. This is a factor that could make or break the storm. This is a factor that climatologically it doesn't fit for this time of year, or it doesn't fit with the MJO phase or the La Nina state or something of that nature. So the question of climate change, there are factors in climate change, like the warming of the upper troposphere and the rapid cooling of the stratosphere, that we've seen improvements in modeling. And it does impact the climate models, the long range, the seasonal models, those models. That definitely is a factor. Another climate change impact, not necessarily what you might be thinking about in the news, would be the volcano eruptions. That is a factor that impacts model guidance because you're adding more particulate into the atmosphere and you're enhancing short waves and you're enhancing the movement of the atmosphere and the circulation not only in the vertical but in the horizontal, and you're impacting different mechanisms in the stratosphere and the troposphere and how that is all evolving. Then there are more localized climate change factors like urban heat island effect that might be enhancing tornadic abilities, that might be enhancing the potential for snowfall, that could be enhancing the snowfall rates at times. I say could because there's still a lot of research that needs to be done on this. So I'm never one to be absolutist. I'm not an absolutist in these questions. So yeah, I mean, there are factors, but in terms of the model guidance right now, I'm sorry, as someone who comes from a time where you couldn't trust model guidance 3 days out because it literally would produce a hurricane over New York City, to where we are now. Where we are now, you could take your education and say, okay, this needs to be adjusted or this could change, but here are the potentials. Here is where we're looking for this stormy pattern. When I went to college 20 years ago, you could not really do that. You can kind of guess, kind of get an idea, but it was really, really poor. And forget about trusting teleconnections. So, no, I don't buy the argument that the model guidance is struggling because of climate change factors. I think some meteorologists are struggling because they're relying far too much on model guidance and not looking at what is possible. And that brings us to snow maps. And let me bring one up. Let's see here. Okay, here's a snow map 24 hours out on the European guidance. And it looks really good, you know. It looks like, hey, look, we can make our forecast. There it is. Copy, paste, there we go. Boom. I wish it was that easy. Why can't I use this model, guys, verbatim? Okay. This map, and many like it, assume a 10-to-1 liquid ratio and assume all snow. Some model guidance, some snow maps out there in the public, take snow, sleet, and freezing rain and considers that all to be snow. I'm not going to name names of what public ones do that, but there are plenty. Snow maps are the worst thing a meteorologist should ever use. Not because I'm a purist, but because it leads to a whole lot of errors. You see, what this map doesn't tell you is what is the ground temperatures. It doesn't tell you what the real ratios are. In this case, this storm's going to have an 8-to-1 ratio at times. And there's going to be potential for mixing with sleet. So is everyone going to get 6 inches like this blotch here? Well, there could be a support for some mesoscale banding for a very short period of time. But you also have to consider the timing of this. And you have to consider the evolution of the 500 millibar pattern. So when I look at this, I see a whole lot of errors here. And it's a bit different from what I have in my going forecast. It's not too far off, but I had to make some tweaks because of these factors. Snow maps and other types of model output are going to have large error because they're only supposed to be a guide, not a crystal ball. So not so much the general public, but meteorologists. When you say, hey, look, there's the models aren't performing well, or the models failed in the forecast, that's not really accurate. Your job and my job is to take model guidance and make some sense of it. And that means that also being responsible in what we put out there. So that when we create our forecasts, it's just not a copy and paste of the GFS, European, or the Canadian. Okay? So that's my spiel on climate change and model guidance and whether there's an actual change. Again, I think the problem is perspective. My perspective is I dealt with model guidance that was god awful to begin with, but groundbreaking at its time. And you guys, well, a lot of you guys get to live in the golden age of model data. And I think that's a factor. So now that we've talked about that, I'm going to get to all the storms, and I'm going to have a nice long chat about this. So definitely load up all your questions on YouTube. And of course, I know a lot of you guys out there in the premium chat definitely, wow, it is rocking and rolling. So definitely keep on firing those questions. I will be answering them. But what I wanted to do first is go over the overall pattern where we're at, and then we'll talk about the individual storms and where I think we're heading on this. As far as, well, let me start off first with where we're going. And I just put this out in the premium discussions for long range thoughts. So let's just talk about this. Tropical forcing first. Well, we have officially killed our La Nina. Okay, as far as La Nina itself, it's gone. It's dead. Long live the death of that. Okay, we are done with La Nina. Thank you. However, we're still dealing with some lingering atmospheric echoes of La Nina. Okay, this is kind of like a ghost La Nina now. So you still have some echoes and some impacts to it, but we don't have the same robust influence. At the same time, we clearly have our MJO impact. I mean, this is a very strong MJO signal. One thing that's very interesting, though, is that the MJO is, well, it's crashing after about 48 hours from now. I mean, it is free falling. It's going from very strong to neutral in the span of 10 days. The reason why this is important is because this is essentially the death knell of our zombie winter, so to speak. You know, it's kind of ironic we didn't get any type of winter-like conditions until we got to meteorological spring. Go figure. So, as one would say, lousy March weather. The MJO is going to be crashing rapidly, and what I see this doing is that it is going to amplify the subtropical jet stream. And we're already starting to hear all sorts of news about another atmospheric river, so to speak. It's just a very strong jet stream, moisture-loaded jet stream, slamming into California. This is going to send shortwave after shortwave into the California coast. And when that happens, our winter weather pattern, if you want to call it that, will be coming to an end. So once you start to see the first really big storm, Hun, can you pass me a tissue real fast? And the other thing I know coming on in spring is allergies. Pardon me for 1 second.
Yeah, I'm getting hit too.
Isn't it fun? Yay, spring. Thunderstorms and allergies, fun times. And also when you're cleaning a house, new house, and all the dust and dirt. Oh, boy. Yeah, that's been fun. Anyway, so the rapid decline of the MJO is going to enhance this jet stream. And I'll pull it up here. Okay, so here we go. This is beautiful. Look at this jet stream now. Because of what we're seeing changes in the tropical forcing and this spike and then crash, right? That's going to lead to this puppy here really getting enhanced and amplified and then slam right into California. Now what that does is that it creates this whole pattern to become more progressive. But at the same time, this is happening. The polar vortex is heading back towards the North Pole and strengthening just a little bit before doing its typical spring collapse. So what does this do? Well, while the subtropical jet stream is rapidly enhancing and amplifying, the polar jet stream starts to get pulled northward and contracts. Why? Because our thermal gradients start to weaken. So the amplification and wavelengths in the polar jet stream begin to contract, and they aren't as strong. So what you end up with is a gradual pull north of the polar jet stream. And you can see this also in the ensemble guidance, you see it in the GFS guidance. Our dominant influence is no longer the polar jet stream, it's the subtropical jet stream. And instead of polar shortwaves marching across the country, it's Pacific shortwaves. And instead of talking about massive winter storms, we're now talking about severe weather outbreaks and severe thunderstorms and tornadoes. Not for here, but for the plains and so on and so forth. I know we're going to get a severe thunderstorm question. I know it's coming. So not for here, at least not yet, but certainly the plains, Tennessee River Valley, Mississippi River Valley, locations like that. So right now, right this minute through midweek is going to be your best potential for winter-like precipitation. It's going to be your best potential for winter storms. But we have some problems. When we take a look, let's look at the GFS, because I use the European a lot. To be fair, I do use it a lot. I use it and I mix it with the European ensembles and the GFS ensembles. What I do is I look at all three and then I kind of blend them together in my head. I know it sounds weird, but I just kind of see it, right? So when I'm looking at the GFS here, what would I be watching? Well, what I am watching is how fast the ridges in the west get knocked down. And so as a result, everything gets pushed along. And this is in the polar jet stream. We're not talking about the subtropical. So when I see that, it's a warning sign to me. And this is why I was not running around on my Twitter feed getting all excited every time a model, whether it's the European, the GFS, the Canadian, or I guess now what is it, the Korean someone's pulling out now, when they start posting these solutions, because the very progressive nature that's showing up on the GFS, on the European, of the Pacific pattern, not necessarily the Atlantic pattern, but the Pacific pattern, is a warning sign against going for any extreme solution. And certainly a warning sign against any stalling, slow, low pressure system. Is it possible? Yes. Is it probable? No. What would you need to happen? I think you've heard this before. The perfect scenario. How many times have we seen that this winter? 0. So what are we really dealing with here? Well, let's start off first with our first system here. And here we go. And our first system is a Pacific origin system that interacts with a polar shortwave right around Thursday night, tomorrow night, right around the upper Midwest. And because that interaction closes off into an upper level low, and it reaches peak intensity right around Friday night over the eastern Great Lakes and western Pennsylvania. Now, when I look at this scenario, I see a lot of interesting things. I see a lot of divergence and diffluence, a lot of strong PVA. I see the support for confluence up north so we can get some colder air funneling in. I also see support at 850 millibars. And I pulled this up here for an area of frontogenesis here. But our 850 millibar low is off to our west. That's important because that means warm air transport. So we have a nice gradient here, but we have warm air transport. Now, a key thing to remember in March, even in the evening hours and overnight hours, when you have your 850 millibar temperatures around 0, -2, Yes, you can get snow, but it doesn't translate to the same surface temperatures it did in January. Now, granted, during the middle of the day, you're going to maximize your temperatures and you're going to be in the 40s, and we're talking about mid 40s, even though your 850 millibar temperatures are -2. When it's at night, more likely to be in the mid 30s. Okay, so it can work, but you're also dealing with a very wet snow in this type of thermal gradient, in this type of thermal profile. And you're dealing with constant warm air transport, so you're dealing with warm pockets moving in. 925 millibar temperatures are warmer in this scenario. So in this scenario, what you have is a pattern, an atmosphere, an environment that supports very wet snow, sleet, and rain. Not pure snow. If we were talking 6 weeks earlier, this would be a moderate to heavy snowfall event all the way down to the coastal plain. But it's not. It's March. We're dealing with a warmer boundary layer, a warmer surface. So when I look at this, those are my first thoughts looking at this upper level low. And then I see this rapid weakening and all of your strong lifting moving off the coast really fast. So your support for intense precipitation is rapidly leaving. And you don't have a lot of cold air transport to follow just yet until you get towards the morning hours. But by then, all of your strong lifting is leaving the area. And your overall storm is redeveloping, transitioning far out into the Atlantic. So you're getting a lot of stretching in the atmosphere. So what you do then is take a look at the moisture involved here. Marginal. In the other event that we had a couple of days ago, we had very heavy bursts of snow. What I found, and what gave me confidence that this was going to occur, was that we had an enhancement of precipitable water values that allowed for that intense snowfall rate. In this scenario, I have no such signal. All that is focused where? Out in the Atlantic, where the stronger lifting is. If this signal was showing up here, we'd be looking at a far different scenario here. In the meantime, I do apologize if you hear some rumbling in the background. Those are either children or pro wrestlers. I'm not sure yet. Could be both. Children pro wrestlers. Well,
Circus troupe, I think.
Circus troupe. Yeah, that could work too. All right. So what this looks like in our model guidance here is this burst of snow. And notice the model guidance now is starting to handle this more as rain on the coastal plain. It's probably rain and sleet on Long Island. And you got your snow here. I don't like the heavier band of snow on New Jersey because I don't really have that phonogenesis in any other area. So I think that might be a convective feedback error. I would far more likely believe that over central Pennsylvania. I would far likely believe that here than here. I like that idea here, not so much here. And I look at other model guidance. Let's see here. Here. The NAM model guidance. You can see that evolution. See, I like that heavier burst here. Allentown, Reading, Harrisburg. And it drops in. So when I look at this, I'll pull up. I'll give you guys a sneak peek on, let's see here, impact map. So here is a sneak peek of what I'm kind of expecting. I'll probably put out a public map officially probably tomorrow afternoon, tomorrow evening. But basically, I'm looking at not a lot on the coast, obviously, but I think away from the coast, right where we have that heavier burst. I like that idea, 3 to 6 inches. I know some model guidance is going higher than that, but I don't like a snow ratio of 10 to 1. And I have to consider the ground. I also have to consider some of the dry air out ahead of this. So that's kind of what I'm looking at here. It kind of looks like a P in a way. With this storm, it's a fast-moving storm. It has a lot of limiting factors, and the transition towards the Atlantic is because everything's kicking this right out. Now that takes us to our next storm for Monday. Again, we have a ridge axis briefly, but one major problem. This trough axis here is positively tilted. It's also showing us up the same thing on the GFS. Let's pull up the GFS. Let's see if we can pull that up here. Let's see. We'll pull up the 500 millibar vorticity. We'll do 12Z to fair comparison. And there you have it. That positively tilt. The reason why you want a negative tilt is because if the trough was like this, okay, then what would happen was that this feature would be captured faster. You'd be able to pull in colder air. The whole storm slows down, and it's able to maximize this ridge axis. But because this feature is basically causing this to drag, that doesn't allow it to happen. And it's not showing up on any model guidance. So this is why I'm staying away from the idea of a full trap. Let's see here. Like what the European guidance tries to do here, I don't buy it. I think this feature that's out here to around Long Island. Let me go back here. There we go. Trying to rush. This feature right here that gets trapped by this upper level low, it doesn't make any physical sense. So this is why I don't buy this. When I take a look at the GFS version of this, everything just keeps on marching along. And then when I look at the ensemble version of this, let's see, I think it's one of these. I pull it up here. Here we are. The surface solution tries to pull the same thing. Now, why am I skeptical of this? Because when I look at the 500 millibar pattern here for this setup, I got a trough kicking that ridge to the east on every model we have. That's a progressive pattern. It's the same song and dance. 7 days ago, the storm for Saturday was supposed to drop 20 some odd inches of snow in New York City. Now we're struggling to see one. Why? Because there's so many short waves moving around that it's trying to amplify everything, and because of the amplification, it produces an erroneous slowdown of the pattern. But the same signal keeps on showing up, which is this ridge axis getting kicked to the east. And the faster it gets kicked, the more likely the whole storm and the whole setup gets pushed out to the east. So while forecasting for a major winter storm during the weekend in March sounds like fun, definitely use plenty of coffee, and God knows I haven't done much in terms of winter forecasting this year in terms of snow forecasting and doing live coverage for a storm event. But I see too many signals here that tell me, no, this doesn't look reasonable. Now, if you're in the Green and White Mountains, sure. If you're in Maine, sure. But I don't really see this type of slowdown. I see this just kind of progressing on through and kicking on through. Now, what would make me change my mind is if this feature is actually further west. Let's say it's back here. That allows this ridge to stay amplified, and that would allow this trough to be neutral, the polar trough. So what would I need to see happen? And let's see here. Okay. So we're at this point here, right? I need this trough to be back further west, this to be more amplified, this to be neutral, as in this trough. Let me see if I can find a way to draw this thing. I guess not. Basically, this trough would have to be cutting through Michigan, okay? If that happened, then the shortwave here gets captured, game on. But until I see that happening, I am very skeptical of any type of heavy snowfall, even for the Poconos and Catskills. I mean, you could pull off a 3 to 6, 4 to 8 type scenario, but these solutions of 12, 20, 18 inches of snow, I don't buy it because the storm isn't going to be able to hang around long enough. It's going to get kicked right out because another short wave is coming in and another short wave is coming in, and California is going to make up for the drought that it's been dealing with, all in a 2-month span, because we're dealing with a very active Pacific pattern. So those are my thoughts on the storms. Those are my thoughts on climate. And let's see, is there anything else I need to touch on? I think that pretty much covers everything for this evening. But now I'm going to take your questions, and let's see what we have here. Well, we have a lot of questions here in the YouTube and a lot of questions here in premium. So of course we will knock off all the premium questions, and I'll take the best questions on YouTube. Let's see here. We got a lot of stuff here. Okay. All right. So once again, a big jet streak across the Pacific and Asia. Yeah. I mean, this thing's monster. Now, remember, the last time we had this type of jet streak, it was a little bit further north because it constituted more of the polar jet stream, and we didn't have that disruption in the polar vortex that we saw. In fact, we were seeing a consolidation. So it was kind of like the worst case scenario. You had a rampant jet streak in the subtropical jet stream combined with a rampant jet streak in the polar jet stream because the polar vortex was consolidated and strengthening, and it just ran from Japan all the way into the central California coast. This time it's suppressed a little bit further south because the polar jet stream isn't playing along just yet. Keyword is just yet. Once the polar vortex starts to consolidate, then you'll really see this rocking and rolling. I am skeptical about the claim by the alarmists about synoptic models not working because there have been so many sky is falling claims. It's hard to give any of them any credence. It's understandable to feel that way. I've always gone middle of the road because that's where the data takes me. And while I agree that there are certainly some challenges in the synoptic models, and there's certainly has to be some considerations, especially in mesoscale models, in terms of urban heat island effect, in terms of what we're seeing just in the Delaware River Valley with the potential for tornadoes. That's certainly a man-made influence. You can't tell me it's not. Based on just the fact of me living here for the past, God, I'm going to feel old, 40 years, all right? So I know for a fact in my teens and my 20s, we barely, if ever, had a tornado around here. And if we did, it would be a very, very special event. Now we're having them in February.
Yeah, they were usually like an offshoot of like a hurricane.
Right, hurricane, something of that nature. So a tropical influence. In this case, we're seeing it out of cold fronts. So there's a lot of research going into it. I know Rutgers is doing some research on this. So I do think that there are certainly some impacts. But as far as the model guidance right now, no. Model guidance is just fine. It's just that some people are relying on it too much. As for this year's modeling being wrong, I blame the big volcano. Yeah, I agree with that. I agree it's certainly some challenges because that is a scenario. Remember what I said at the beginning of this winter, that I would have very low confidence in model guidance beyond 5 days because there are going to be a lot of interaction of shortwaves because of the volcanic influence. And that's essentially what we saw. And literally in the winter forecast, I said, watch out for plenty of ghosts of storms and plenty of phantoms. And that's exactly what we've been seeing. It's changing by questioning the amount people are having as compared to natural. Well, all right. I will put it this way. You can't put in a lot of carbon and methane in the atmosphere and not have a significant impact. On the other hand, there are natural changes, volcanic changes. So you have to weigh it, okay? Remember, I have no doubt that we're seeing man-made climate change. But I also don't believe the world's ending or that we're all going to die or that it's a climate emergency or some crazy stuff like that. But we are definitely having changes and influences. I will say this, I'd rather have a warmer planet than a colder one. Warmer planet, mammals can adjust to warmer climates. You cannot adjust to colder climates because you can't grow things. You have to eat. You have to grow plants. If you have a cold planet, you can't grow plants. So trust me, you'd rather have a warm planet than a cold one. I'm not seeing people don't have an impact, as you point out, or urban neon effect. Definitely have an impact on gas emissions, but a single volcano emits more CO2 than all the cars on Earth. Yes and no. It's more complicated than that. I think that I don't want to get too much in a rant on climate change. I'll put it this way. Yes, a volcano can put out more CO2, but it's a different factor in the way that in the type of CO2 we're putting out and how we're influencing it. The Earth's environment can gradually change with volcanic influence. But how we're changing the biomass is totally a different scenario. My expectation for the near urban heat-on suburbs of Union County is rain, wet snow, because wet rain, maybe a small slush accumulation on grassy surfaces. Anything more would be a pleasant, hey, it snowed. Yeah, pretty much. I was looking at the 250 millibar jet streaks where the amplification is, and the angles of the amplification, it seems implausible that there could be any real snow on the coast and urban corridors. It seems like the perfect scenario for shortwaves to just miss each other or be mistimed. They are speeding along and at the wrong angles. Yeah, for the most part, that's essentially what we're seeing here. It's certainly an energetic pattern. It's just really difficult for those shortwaves to interact just right. I'm old enough to remember those old models, and it was a real treat when the old Weather Channel actually showed them. Yep, that was definitely an interesting time. Is the MJO crash related to the big jet streak at 250 millibars? It does have some. The MJO is influencing that evolution, yes. If only California had built new reservoirs. Yeah, tell me about it. Will you be adding a pollen report to the premium forecast? No. But maybe. That's tough to do. Honestly, I mean, the government does, National Weather Service does an excellent job of collecting that data. I would not be a good source for that, to be honest with you. The ground is very warm for this time of year as compared to most winters. Yes, that's a very important factor. The snowpack you normally would expect in these type of scenarios is nowhere near what you would want. So that's certainly a good point. It's going to allow for your air masses to moderate much faster. And all, as far as March is concerned, I forgot his name. He put out an excellent post. I think it was Joe, where you had the March snow that we just had, and then you saw the visible satellite and that snow just evaporating, even 6 inches of snow evaporating like that under the warmth of the March sun. So yeah, that's certainly a factor. Perhaps severe system will have enough of live casts, not that I want to see severe storms at all. See, doing live casts for severe thunderstorms is very difficult because it's a very short term, and sometimes it takes a while for me to prepare for those live casts, but it's something that I'm certainly going to be trying to do. My feeling about a major winter storm for our area before next winter is that it only happens for if the movie Bruce Almighty happens in real life. Yeah, that's probably true. Tropical stuff happened in the 50s, 60s, and 70s, though I remember the massive floods of the 1970s tropical systems. Oh, absolutely. Look, here's the thing. I've always said that when talking about climate, it's a bad idea to use major storms in general as a bellwether for climate. And the reason why I say that is because you could always look towards the past and say, well, it happened here, it happened here, it happened there. It's a poor argument to make because just because there's climate change or you reduce your CO2 gases doesn't mean that major storms go away or the frequency of them declines. I don't buy that for a second because the data doesn't show that. So I always say it's always a bad argument to say, well, if we did this, then the storms would never happen and Sandy would never happen and so on and so forth. It's a ridiculous, stupid argument because it has no support in data nor climatology. Do you think temperatures would be below normal in the mid-Atlantic for the rest of March and April? Most of March, yes. If this jet streak reaches the California coast and we get that surge of Pacific air marching across the country, I think we trend towards near normal by the end of March, and then we start to get this near to slightly above normal regime in April. That will depend on how much Pacific air is able to surge across the country. Perhaps an ad linked in the observation section for pollen stuff. Yeah, I could always check that out and see if I can find something. Let's check out YouTube, see what's crazy. Holy smokes, my God. All right.
They like you.
Let's see. I was in the doctor's office yesterday and some guy was talking about how we are getting 3 feet of snow next Tuesday through Thursday. Oh, Jesus. See, I love the fact that everyone can get this mild guidance, but I also hate it because the worst thing that these private weather companies that make the mild data ever did was create these god-awful snow maps. Look, I get why they did it. It's because, hey, look, we can get our image all across social media and get free advertisement, and everyone who loves snow will flock to them and get all excited and then wonder what happened to it 2 days later. But for us, for meteorologists, first of all, if you're studying meteorology, if you're a young meteorologist, what I want you to do is I want you to take that snow map. I want you to print it out. I want you to lay it down flat, make it all nice, put it in a garbage can, get some kerosene, and burn it. The snow map is the worst thing that has ever happened to meteorology, in my opinion, as far as operational forecasters. You use a QPF, you use your temperature profiles, and you use what you learned in college, in your classes. Snow maps are, and this is no slam against anybody, snow maps are for amateurs that don't understand the science. Sorry, it is. And it creates more confusion than it actually helps anybody. And it creates what we just had here. I was in the doctor's office yesterday and some guy was talking about we're getting 3 feet of snow. You see what I mean? Is the potential there for a significant snow event the weekend of daylight savings time come this weekend? You know, the whole daylight savings time thing really doesn't matter to me as far as like impacts on weather. But the fact we're going to daylight savings time gives you an idea how much sun we're seeing, right? We're seeing that shift. So that kind of gives you an idea, okay, we have a stronger and stronger sun angle. Every day we go, every day we move forward, the sun angle is getting stronger and stronger, which means it's getting harder and harder for accumulating snow. So that factor you have to consider. Is it possible? Yes. But you need a whole hell of a lot of lifting in order to pull it off. Let's see here. Let's see. Did you see the 12Z Korean model? No. And I want to touch on this. When I am forecasting, and this is just something I do, I don't look at every model. Because what I think what happens is that you get data paralysis, okay? You're looking at so much data and looking at so many different things that you become paralyzed and you can't forecast. And I had this problem when I was younger, especially in my 30s when we were starting to get all these models to come out. And I'd be like, wow, let me look at all this data. Let me look, and I'd be stuck for hours because I wouldn't know what to believe and what to work with and what to do and what does this model do and what does that model do. Cut it down to 2 models. For me, it's European GFS. The ensembles of those models. And then when you take that, compare that to the observations and make your forecast. Don't chase all these other models because all it does is lead to confusion and data paralysis. If the Korean model with its 948 millibar low off Long Island with 2 to 3 feet of snow from Philly to Boston. Okay. So if someone was to show you that model, the first thing you would say is that show me the 500 millibar pattern, because what that would, in order to have that happen, you have to fundamentally change the Pacific pattern. That's what you would need. If it doesn't show that, it's a waste of your time. Let's see. What would we need for more cold air? Well, I already answered that. Could the Saturday storm bring a bit of snow to Philly? Bit of snow. I could definitely see snow. I don't think it will accumulate all that much. But I definitely would see snow in the air. In the morning, I wouldn't be surprised if we get dusting, like on cold surfaces and stuff. I think it'll be difficult on the pavement. How does the weekend system impact the potential storm for next week? Because of the fast nature of the pattern, it really doesn't have too much of an impact. The storm on Saturday makes the storm on Monday, Tuesday possible and slows down the pattern enough to allow for the subtropical shortwave to track towards the Delmarva coast, but that's about it. The whole planet was warm when the dinosaurs were here. I wonder what cars they were driving. Well, all right. First of all, different atmospheric setup. The planet itself was in a slightly different orbit evolution. And the evolution of that climate took millions of years, not decades. So it's not really comparable. You also had a lot of volcanic eruption. A lot of stuff going on with that. And the oceans were different as well, as far as the composition, the chemical composition. So it would be nothing like what we have today. And trust me, we do not want to get to those warm temperatures either, because no one wants those giant bugs. I don't know about you, but I do not need giant bumblebees and hornets. Okay? Their hornets are like this big. Do you want a hornet that's this big? I don't. Let's see here. Geez.
We can be a little bit more polite in the chat.
Well, not surprised. Let's see here. What else do we got here? Back to the premium chat now. All right. The easiest way to stop large damage in coastal areas is to stop building cities on barrier islands. That I agree with. Any early thoughts on El Nino? El Nino is coming. It is on the way. It is going to have an impact on the tropics. I have no idea how strong it will be, but there are indications that it would be weak to moderate. Orientation could be central. Not sure yet. That's debatable. That could change. I I have no idea what impact it'll have on the winter. So don't let's not even go there. Let's just get to the summer. I think they'll have an impact in causing more shear in the tropical Atlantic, and I think that's going to lead to a below normal hurricane season. We'll see. I think that it will lead to an active weather pattern for the United States. And I think that the summer pattern is going to feature a few very interesting rainstorms. That's my early thoughts on El Nino. Even the surface maps and the operational models, because so many people just look at the surface map and don't look at the... Okay, this is a great point. Okay, all right. Let me pull this up here. Let me see if I can find a really good example here. Okay, let's see here. So there's the European guidance doing its crazy thing. Okay. So in this scenario, you have this intensification going on right here. While that's happening, if I could pick up the right map, here we are. You have this upper level low forming. Now, here is the error. 150 hours, your upper level low is to the east of Long Island. At the same time, at that same time period, you have your surface low to the east of Long Island. What is the problem with this solution? Problem is it's vertically stacked. The storm is vertically stacked while it's intensifying. The two cannot be the same. Either this storm is nowhere near strong and it's weakening, or this surface low pressure system is out here. Because a storm that has a surface low and an upper level low on top of each other can no longer rapidly intensify. Cold core systems have to be slanted like this. So your upper level low is here, your surface low is here. So it's like this in the atmosphere. So that allows for divergence and diffluence and air to rise. When the upper level low is centered over the surface low, the air is no longer rising. It kind of gets capped. And so it kind of chokes it off. So you're choking off the engine here. So when I look at this solution and then compare that to the upper level pattern, there's an error here. Something's not right. This storm should be further east if this solution verifies. Or this storm needs to be much weaker if the track is correct. But they both cannot happen. Or, one last possible solution, the storm intensifies much earlier, further to the east, and then gets pulled back west and weakens, which means that precipitation shield is nowhere near as strong. It's weakening because the lifting is weakening. So that's a great example. If you want 3 feet of snow or more, go to Sierra Nevada. Yeah, that's true. Or the Rockies in general, yeah. We are 2 weeks away from the same sun angle as the 3rd week in September. Yeah, that's definitely true as well. Yeah, absolutely. Let's see here. I'm going to contact Handy Smurf to use weather machine and change the sun in blue skies. Oh, jeez. Smurfs. I remember that. I hope they don't do a reboot of that. God, that'd be horrible.
They did the movies, remember?
They did. Oh, that's right.
Yeah.
Oh, God, that was horrendous. I think I saw that. Yeah, you're right. I think we saw that for like a hot minute.
No, I didn't watch it beyond just seeing the trailer.
No, that's what I mean. We saw a trailer and we said, nope. By the way, why can't anyone ever create any, like, what's with all the reboots? What do you guys think about that? I mean, look, just create something new. Stop rebooting stuff. And for God's sakes, leave Scooby-Doo alone. Man, all I know is that Shaggy was my spirit animal. That guy could eat and I could eat, and that guy, he ate everything. He was no vegan.
I love Scooby.
I love Scooby too. Let's get Scooby. Let's get a dog like Scooby. How about that?
You want a Great Dane?
Yeah, let's get a Great Dane. We can have him. He could be like a mascot for the new weather lab. Roar. That'd be great. Boy, that'd be awesome. Let's see here. We have any more questions? Let's take a look and see some observations. See if there's anything. Look how intense this storm is coming into the West Coast. Holy Bob Dole, look at that. Wow. That is one intense storm. That has plenty of energy. I think that late March and April is going to be known for a lot of severe weather. A lot of severe weather. And it's going to be driven by the subtropical jet stream, and it is going to get nasty around Oklahoma, Texas, Arkansas, Missouri, and march right into the mid-Atlantic. And I would not be surprised if our summer ends up with above normal precipitation, which of course isn't going to make me too happy because it's going to interrupt my Mets games. Better not, because I want to watch all my Mets games. But the way that they changed the game recently with this pitch clock, we might be done with the Mets game in 2 hours, hon. What do you think of that? You only have to suffer baseball each night for 2 hours.
I'll be busy.
You'll be busy. Well, yeah, that's right. Because we'll have a house. That's true. Hey, you know what that means? I could also cheer for the Mets louder than I was in the apartment because I don't have to worry about I can actually run out into the backyard and scream, "Let's go Mets," and then shoot fireworks off every time they hit a home run. That would work, right? I think that would be cool. I think that is it for tonight. We're almost at 9 o'clock. Holy smokes, we've moved through. We had plenty to talk about. Thank you again for all of your wonderful questions. You guys did an outstanding. Any flood concerns for our area this spring? Excellent question to end this chat. Off the bat, no. I think we'll be fine initially. But if we end up with the type of subtropical jet stream I think we might be heading towards, I think we can move in that direction by the time we get to the summer. But initially, no. Okay? I think initially we'll be fine. But going forward, might have some issues. So that's it for tonight. Thank you again for following and visiting and being here and asking all these great questions and discussing climate change and Korean models and everything else. I really appreciate it. And, well, as always, stay safe out there.